A job is not executed just by placing modules on the canvas. We have to click on the Run button to make it happen as we have defined. When they are marked with green checks, it means the job is completed. Let's try Visualize by clicking on the bottom circle of Join Data. Then you can see that the features.csv file and the train.csv file have been merged. There is store and then date. It is followed by temperature, fuel price, CPI, and unemployed, which we had before the merge. But now we have department merged from the train.csv data. Department has values from min 1 to max 99. And then we have weekly sales. As the last one, we have is holiday, whether it was a holiday or not. The data ended up with 9 columns and 421,570 rows. This is really a latte. If we tried this job on Excel, we would have severe lag. But with Azure's high-performance CPU, GPU, and fast data processing capability, we are able to pre-process and model the data this big fast. Please check if your screen shows the same number of columns and rows as mine. So we have merged the features.csv file and the train.csv file. Let's try merging the store.file too. Get the store.csv file from my datasets and place it here like this. Since we need to merge data again, we need to use join data once more. So, place join data below join data. Let's connect the circles like this. And then we need to give key values from each table. Go to the Properties window, and we can select Store Only as a key value from the left table. Click on the check button and select Store Only from the right table, Store.csv, and move it to the right. And check. Here again, you can leave Match Case checked as it is, but you must uncheck the option below to have only one of the two identical store values. After all these, to run the module that we just added. We can click the right mouse button over the module and choose Run Select. And the previous modules will stay the same, and only the last module we added will run on the server. When we see this green check mark, click on the circle at the bottom and choose Visualize to see that the three files have been merged into one, which has 11 columns and more than 420,000 rows. We had up to weekly sales and as holiday before. But we also have 3 store types. Types A, B, or C. And the store sizes. The size has the mean of this value. And the min value and the max value seem to have a big difference. We can tell that some stores are quite bigger than other smaller stores. We've learned how to merge data so far. Hope everyone is following. Next, let's try pre-processing the merged data. Those who have the merged data, please check the number of data again. It would be convenient if we could use this data as it is, but we can't until we make some modifications. Do you think you can find anything wrong by clicking on each data? We have some columns we need to modify. It will be great if you can find them on your own. Let's look at them one at a time. Which one should be modified? First, we need to modify the store column. It looks fine, but why do we need to modify it? We have the values of the stores from store 1 to store 45. Each value is in numbers like 1, 2, 3, 4, 5, and so on. But when we train a machine learning model with these, we have to teach the machine that they are not numeric values. It is because when a computer is inputted with numbers, it will just consider 2 more important than 1 because 2 is larger than 1, 3 more important because 3 is larger, and ultimately judge that 45 is the most important. But the numbers 1 or 2 are just for store references for the sake of convenience, not for scoring or valuing the stores. So, we need to do something that says the numbers do not represent numeric values, but they represent groups. What about other columns than store? Have you found any? That's right. The department column is shown in numbers. Departments 1, 2, and 3 are in numbers, but they don't have hierarchical orders or differences between good or bad. So, we need to say they don't have any numeric values. Do you see anything else? Not anymore. Let's define these numbers in store and department as non-numeric values. Go to the module category. Under Data Transformation, go to Manipulation. And in the middle of the list, get Edit Metadata. Place Edit Metadata below Join Data and connect them together like this. Edit Metadata does not change the values of data, but it changes the properties or forms of the data. With Edit Metadata selected, look at the Properties window in the right. Click on Launch Column Selector to choose which columns to modify among the columns we have. Then, on the left side, we will see all of the 11 columns we have. The columns we need to edit are only 2: Store and Department. Move them to the right side and check. Now we have these 2 columns selected. What we need to edit is not data type, but categorical right below. Categorical defines if a value is a group or not a numerical value. So if you open this, you see Make Categorical. Click on Make Categorical and thereby define the numbers in Store and Department as categorical values, not as numerical values. Select this and run it. By right mouse click on it and run selected, and then the values of data do not change. But the computer recognizes the values as categorical values, not as numerical values. Let's try visualize by clicking on the circle at the bottom. Do you remember we had the min, max, and mean values when we selected store last time? They were automatically calculated because the values were recognized as numeric values. However, they are categorical features now and not recognized as numbers any longer. You can see that department also has been changed to categorical values. We have to run make categorical for all the data values that are described in numbers, but actually don't have numeric values. We've done with these two now. Any more data we need to edit? Anyone found any? We need to change to columns CPI and unemployment. They look okay, but what needs to be edited? We can see that all the values in there are in numbers. But if they are all in numbers, it should automatically calculate values such as mean, max, or mean. But we can see that the values of these two columns are recognized string data, not numeric data. Temperature and fuel price next to them are recognized as numeric values with min and max values. So they are in the correct form that a computer can recognize. CPI and unemployment are recognized as strings. So, we need to tell the computer that they are numbers, not letters. I'll close this window and go get the Edit Metadata module again. Connect it like this. We will connect it with the circle of Edit Metadata above it. Then, let's look at the Properties window of the second Edit Metadata. Open Launch Column Selector. And it will show 11 columns we have. We will move the two columns, CPI and unemployment, that are recognized as strings, to the right side. And check. This time it's not categorical we need to change, but it's data type above it, since we have the wrong data type now. So, open this menu and it gives 6 data types that Azure ML Studio supports. The CPI and unemployment data are with decimal points. So, we can choose floating points to make the computer understand the data as numeric values with decimal points. After this, right mouse click on the new Edit Metadata and choose Run Selected. Like what we have done here, we always need to check our data, if their values are correctly prepared, and determine whether or not we can work with our data as they are. After this, we can use Visualize to see that we have the CPI and unemployment data converted to numeric features as we intended. We can also see that the mean of CPI is 170, and that of unemployment is about 8. All the data we are going to use is prepared and ready now. Preparing data takes longer than you expected. That's right. In machine learning, the most time-consuming and attention-requiring job is not modeling, but it's preparing data. We have practiced importing, merging, and pre-processing the data. Those who have completed the work up to here will continue with what is necessary to train a model in the next session.